So on this video, what we're going to do proving trig identities. So if you want to get a gist on how to simplify, because of proving trig identities, you need the knowledge of simplifying trig identities first. So I'll put the I or link the video in the description, or I'll have it up in the I on top, right? So using proving trig identities, we need all our trig identities, which is this one and this one. It's only this two. Then from this one, we have derived the extra two, which is this and this, right? So let's do the first question on proving trig identities. So let's look at the first example. When proving, what we need to do is we need to make sure that the left hand side, which is this one, is equals to the right hand side. So what we first do is we first take the most complicated side of the equation, then we simplify it so that it matches out with the one we didn't take. So in our case is that we can take this one as being the most complicated, but we can also take this one. But now let's just take this one, right? Because of both, they fairly not complicated, right? So if we take the left hand side, which is this one, we're gonna say left hand side is equals to what? 1 minus sine x divided by cos, right? So here, there isn't any identity that we can use to actually simplify this. So what we're going to do is we're going to multiply it by a reciprocal so that we can form something like this, right? So that's what we're going to do. So we're going to multiply by a reciprocal, which is the reciprocal of 1 minus sine. So the reciprocal of that is going to be multiplied by 1 plus sine x, right? Divided by 1 plus sine x, right? Then what we're going to do is we're going to multiply numerator to numerator and denominator to denominator. So let's do that. So let me put them in a bracket. You're going to say 1 minus sine x, close bracket, 1 plus sine x, right? Divided by cos x, right? Open bracket, 1 plus sine x. Look at this. As we're solving, we see the fact that already we are achieving the 1 plus sine x that we want from the right hand side. So far so good. So now let's simplify the numerator. 1 multiplied by 1 is going to give me 1. Then 1 multiplied by sine x is going to give me positive sine x. Then negative sine x multiplied by 1 is going to give me negative sine x. Then sine x, negative sine x multiplied by sine x is going to give me minus sine x squared, right? Then this whole thing is going to be divided by what? It's going to be divided by cos x, open bracket, 1 plus sine x, close bracket. So now let's continue to simplify it. Let's simplify the numerator. The sine x and negative sine x are going to cancel out because it's going to give us 0. So the numerator, what you're going to be left with, you're going to be left with 1 minus sine squared x divided by what? By cos x, open bracket, 1 plus sine x. Right? So what can we see? We see the fact that the numerator 1 minus sine squared x can be changed into this identity, right? So let's do that. So let's change it into that identity. So it's going to be equals to what? Cos squared x divided by what? Divided by cos x, open bracket, 1 plus sine x, right? Then we know the fact that cos squared x is the same as having two cos's, right? Multiplied with each other. So since we have two of them, one of them is going to cancel with the denominator. So this one's going to cancel with another cos. Let me just cancel the square. So what you're going to be left with, you're going to be left with just cos x, right? Then the cos x is going to be divided by just what? It's going to be divided by 1 plus sine x. And we see the fact that 1 plus sine x is the same as the right hand side. Do you see? We see the fact that we have cos 1 plus sine x, and that is exactly as what we got when we done simplifying the right hand side. So you're going to say this is also equals to the right hand side, right? So this is how it would look. This is the final answer. So now let's look at number 2. We see the fact that number 2 to some degree is similar to number 1. So you can pause this and actually unpause it to see the final solution. So let's solve this, right? We see the fact that again we have 1 plus cos theta divided by sine theta is equals to sine over 1 sine theta over 1 minus cos theta. So as you know, the fact that we're proving, we need to take the left hand side and check whether it's equals to the right hand side, right? So we're going to take the left hand side. So when we take the left hand side, you're going to say left hand side is equals to what? To 1 plus cos theta divided by what? Sine theta. Then you're going to multiply this by its reciprocal of the numerator, which is multiplied by 1 minus cos theta divided by what? By 1 minus cos theta. We see the fact that already we have achieved the 1 minus cos theta for the right hand side. Then we're going to multiply them together. Then I'm just going to multiply from here 1. This is like the same having 2 brackets. 1 multiplied by 1 is going to give me 1. Then 1 multiplied by negative cos theta is going to give me negative cos theta. Positive cos theta multiplied by 1 is going to give me positive cos theta. Then the last one is positive cos theta multiplied by negative cos theta is going to give me negative cos squared theta, right? And this whole thing is going to be divided by what? By sine multiplied by this bracket. So it's going to be sine theta, open bracket, 1 minus cos theta, close bracket. Let's simplify the numerator here. It's going to be 1. The cos thetas are going to cancel out because it's going to give you 0. So it's going to be 1 minus cos squared theta. It's divided by what? By sine theta, open bracket, what? 1 minus cos theta, close bracket. So moving up, let me move the screen up. What do we see? We see the fact that the numerator, we can substitute it with this one, right? So let's do that. 1 minus cos squared theta is going to give us sine squared theta. So it's going to be sine squared theta, right? Divided by sine theta, open bracket, 1 minus cos theta, right? Then here, sine is going to cancel with one of the signs here. So what you're going to have is sine theta, right? Divided by what? Divided by 1 minus cos theta. So let's check whether our final answer matches up with the right hand side. So let's go up. We see the fact that sine theta divided by 1 minus cos theta is the same as what we got. So we're going to say this is equals to the right hand side. So this would be the final answer. So now let's look at question number 3. We have sine squared theta plus open bracket cos theta minus tan theta, close bracket, open another bracket. Cos theta plus tan theta is equals to 1 minus tan squared theta. So now we need to prove that the left hand side is equals to the right hand side, right? As I said, when we're proving, we need to take the most complicated side of the equation, right? So the most complicated side is this one. So we're going to take that one. We're going to say left hand side is equals to sine squared theta plus open bracket cos theta, right? Minus tan theta, close bracket, cos theta plus tan theta, close the bracket, right? Then what we need to do is we need to simplify this part. We see the fact that the thing that we could do right now, because we wanted tan squared, we can actually expand this so that we actually get that, right? So let's do that. So if we leave this alone, so it's going to be sine squared theta, right? Plus, then we're going to say cos multiplied by cos is going to give us cos squared theta, right? Then cos multiplied by this one, cos theta multiplied by tan theta is going to give us positive cos theta multiplied by tan theta. Then here in the bottom is going to be negative tan theta multiplied by cos theta is going to be negative tan theta multiplied by cos theta, right? Then the last one is negative tan theta multiplied by positive theta is going to give us negative tan squared theta, right? What do we see? We see the fact that we have wait, I want to talk about something first. Cos theta, right? Cos theta multiplied by tan theta is the same as tan theta multiplied by cos theta. Since these two are the same thing, they're going to cancel out, so they're going to be equals to 0, right? So now let's write the simplified version in the bottom. So it's going to be sine squared theta plus cos squared theta, right, minus tan squared theta. Do you see the fact that slowly we are arriving to the answer? We have tan squared theta. That's correct. Now we need a 1. But look at this from our identity. We know the fact that sine squared theta plus cos squared theta is equals to 1. So we can replace this whole thing by 1. So this is the same as saying 1 minus tan squared theta, right? So therefore this and this are the same thing. So this is equals to the right hand side. Then we're done with the question. So now let's look at question number 4, right? We know the fact that we need to make sure that the left hand side is equals to the right hand side, right? And we need to take the one that's more complicated and simplify it. So our most complicated one is the left hand side. So we're going to say left hand side, right, is equals to 1 over cos theta minus cos theta multiplied by tan theta, right? Minus tan theta squared divided by 1. And then what we're going to do is we're gonna first change this one into a trig ratio. Remember this. Remember the fact that we have tan theta is equals to sine theta over cos theta. Even the square one can be changed, but you need to square this side, right? Even if it's to the power 3, you can change it. If it's tan, it's going to be, if it was, for example, tan cubed theta, right? You can change it into sine cubed theta divided by cos cubed theta. So we can change this into sine squared theta divided by cos squared theta. So let's change that one. So it's going to be equals to 1 over cos theta minus cos theta, right? Multiplied by what? By sine multiplied by sine squared theta divided by cos squared theta, coming from this one, right? Then what do we see? We see the fact that here in the numerator, this is the same as divided by 1. Here in the numerator, we have cos theta, and here in the denominator, we have cos squared theta. So one of the cos are going to cancel out because there's 2 of them. So we're going to write this as 1 over cos theta, right? Minus this one's going to cancel out with 1 of this one. So it's going to be in the numerator. What you're going to be left with? You're going to be left with sine squared theta, right, divided by just cos theta, right? And what do we see? Let me take it up. What do we see? We see something. We see the fact that, what do we see? We see the fact that we have a common denominator, so we can put the denominator to be one thing. So you're going to have 1 minus sine squared theta divided by what? Divided by cos theta. You see the fact that this one can be replaced by what? Can be replaced by this one. So let's do that. If we replace that one, it's going to be equals to cos squared theta divided by cos theta, right? Then since the numerator has 2 cos thetas, one is going to cancel out with the denominator. So you're going to have cos theta. Then we need to check whether is this the same as the right hand side. So let's do that. We see that our right hand side is cos theta. So therefore, this is equals to the right hand side. So this is the full thing. So now let's look at question number 5. We have what? We know the fact that we need to prove that the left hand side is equals to the right hand side, right? And when proving, we need to take the one with the most complicated side, which is in our case is the right hand side, and simplify it so that it matches with the left hand side, which is, this is in our case, right? So we're going to take the right hand side. So we're going to say right hand side, right, is going to be equals to sine, open bracket, sine theta plus cos theta minus 1 over sine theta plus cos theta. So now we see the fact that sine theta plus cos theta here and here they are the same. So we see the fact that from the left hand side we need to have what? Sine theta plus cos theta as the what you call this as the denominator, right? So what we need to do is we need to find the LCD, right? So to find the LCD, this one is the same as divided by 1. So we need to multiply the numerators, the denominators together. So let's do that. So 1 multiplied by sine theta plus cos theta is going to be the same as sine theta plus cos theta, right? Then what we're going to do is here, since this one, its numerator is 1, and the whole numerator is sine theta plus cos theta, we need to multiply this and this together. So let's do that. It's going to be sine theta, right, plus cos theta, all to multiplied by this one. So it's going to be what? Sine theta plus cos theta, right? Then this one needs to be multiplied by this one. So it's going to be the same as minus, don't forget the sign, minus 1 multiplied by 1, which is the same as 1, right? So let's simplify the numerator now. So now simplifying the numerator, we need to expand this to bracket. Sine theta plus sine theta is going to give me sine squared theta. Sine theta plus multiplied by cos theta is going to give me what? Positive sine theta and cos theta. Then sine cos theta multiplied by sine theta is going to give me the same thing, sine theta multiplied by cos theta, right? Then the last one is going to be cos theta multiplied by cos theta is going to be the same as cos squared theta. This whole thing is going to be minus, don't forget this minus 1, don't be like me. This whole thing is going to be divided by sine theta plus cos theta, right? So now let's go up. Looking at the identity, we see one of our identity has sine squared theta and cos squared theta. Look at this. We have here sine squared theta positive, and here cos squared theta, which is positive. So we can rearrange this so that we can say it's 1. So let's do that. It's going to be equals to sine squared theta, then it's going to be plus cos squared theta plus this 2 is the same thing, so you're going to say 2 sine theta cos theta, right, minus 1 divided by sine theta cos theta, right? So we see like that this and this are the same, so we're going to have 1 plus 2 sine theta multiplied by cos theta minus 1. This whole thing is going to be divided by what? By sine theta plus cos theta. 1 and positive 1 and negative 1 are going to cancel out because that's going to give us 0. So what are we going to be left with? We're going to be left with 2 sine theta cos theta divided by what? Sine theta plus cos theta. Let's check whether this is the same as our left hand side. We see the fact that our left hand side is exactly same as our right hand side. So we're going to say this is equals to our left hand side, and you're done solving the question. Example number 6, same applies, that we need to prove that the left hand side is equals to the right hand side. That's what we need to do. And to do that, we need to take the most complicated side and simplify it so that it looks exactly like the side that we didn't take. So the side that's complicated is what? Is the left hand side. So we know the fact that left hand side is equals to cos, right, open bracket, sorry, cos theta divided by sine theta plus 10 theta, close bracket, cos theta. So what can we see? The fact that we can substitute this 10 theta by this one. So let's do that. So open bracket again, cos theta divided by sine theta, right? Then plus this one is going to be sine theta divided by cos theta, close bracket, cos theta. So let's go a little bit up. What can we see? We see here the fact that we cannot cancel anything because of there's an addition. So if there's an addition or addition or subtraction, we cannot cancel. We only can cancel when it's multiplication only, right? So now here we need to find the LCD. So the LCD here, it's going to be this one, this denominator multiplied by this one. So it's going to be sine multiplied by cos. So LCD is going to be equals to sine theta multiplied by cos theta, which is the same as sine theta multiplied by cos theta, right? Then what we're going to do is here, since this side doesn't have sine, we're going to multiply the sine here. And since this one, the denominator, does not have cos, we're going to multiply this one here. So that's what we're going to do. So cos is going to be multiplied by cos. So it's going to be open bracket cos theta multiplied by cos theta, right? Plus this one plus this one, so they can balance out. It's going to be sine theta multiplied by sine theta, right? And this whole thing is going to be divided by the LCD, which is this one, which is sine theta multiplied by cos theta, close bracket, cos theta. When we move up, what do we see? We see the fact that this one, let's simplify this one. So open bracket again, it's going to be cos squared theta plus sine squared theta, right? Divided by cos theta multiplied by sine theta is the same thing. Close bracket multiplied by cos theta. Cos theta, cos squared theta plus sine squared theta is the same as equals to 1. So let's simplify it. It's going to be 1 over, let me just say sine theta multiplied by cos theta, right? Multiplied by cos theta. Then we're going to multiply the numerator to the numerator together. So this and this together. 1 multiplied by cos, which is going to give us cos theta divided by sine theta multiplied by cos theta. Then now what can we do? We can cancel out because of these multiplications. So this one and this one is going to cancel out. So what you're going to be left? You're going to be left with 1 sine theta. So now let's check whether what we got in the left hand side is exactly what we need in the right hand side. So we see the fact that our right hand side was what? 1 minus sine theta, and we got 1 minus sine theta. So this is equals to right hand side. So you're done proving.